This lesson goes through a number of ways to collect and display data. There's quite a lot of terminology and there's also some graphs, so you'll probably need to pause the video several times if you're going to take all of the notes down. To start with, when you're collecting information, the whole group that you could use is called the population. So that might be the population of a school or the population of a country. If you're only going to use part of the population, then that's called a sample. A fair sample is like the population. In other words, when you're taking a sample, you want it to be representative of the population. A biased sample is not like most of the population. For example, if you were surveying a sample from a school population, but you ask students of only one year group or only one gender, then that would be a biased sample. There can also be bias in the way that questions are phrased. Now, if you're collecting data by asking people questions, then that's called a survey. And if you're collecting data from the whole population, that's called a census. Let's look at some examples and see if we can identify any possible sources of bias in either the sample or the question being asked. So in this first one, we're looking for the most popular sun cream on the Gold Coast, and the people at a surfing party on the Gold Coast are asked what sun cream they use. So in this case, our population is people on the Gold Coast. If we were to ask everybody on the Gold Coast, then that would be a census of the population. But we're just asking some people at a particular surfing party, so that's a sample. Now, is it a fair sample or a biased sample? Now, we can assume that everybody at the party either surfs or is connected with the surfing community, and so it might be that they all use a particular brand of sun cream that is marketed to surfers. Our sample is biased because it does not represent the whole population of people on the Gold Coast. Secondly, we want to find out whether to introduce a new Year 11 and 12 course, and so students in a Year 10 English class are asked, would you do this course if it was offered? Is this a biased sample? Well, in this case it depends on the class. If it's a school where students are streamed for English in Year 10, then this might be an extension class or it might be a mainstream class. But if it doesn't represent the entire year group, then it's a biased sample. If it's a mixed class of mixed gender and mixed ability, then that would be a fair sample. Finally, we have shoppers in a supermarket asked whether they would prefer to use the new improved Sudso Clean detergent or rotten old brand X. This is an example of a biased question, where the phrasing of the question is influencing the way that people might answer it. Next, I'm going to demonstrate how a stem and leaf plot can be used to collect numerical data. With a stem and leaf plot, we consider the numbers that we're going to be collecting, and in this case we have two-digit numbers. So our tens digit, the first digit, will form our stem, and the units digit will form the leaves. So we construct our stem by writing all the possible tens digits in a vertical column. Now in this case we're collecting ages of voters at a polling booth, assuming that they're willing to tell us their age, that is. As they arrive, we ask their age. The first one is 43. The 40 is already there on the stem, and we add a 3 as a leaf for that stem. Then the next one is 41. So again, with the 40 stem, we have a 1. Then 26, 37, and so on. Once the data have been collected using a stem and leaf plot, we can then display the data in a neater version of the plot. The stem is the same, but this time we rewrite the leaves in order to make it a more useful form of display. Notice that there are no commas between the leaves, and that we line up the numbers in neat columns because this is a form of graph. One final piece of information that this stem and leaf diagram requires is a key. We can choose any number on the stem and leaf plot. I'll just use this first 16 here. So we write 1 stem 6 equals 16 years old. Now for some more different types of data. So get ready to take lots of notes and pause the video as necessary. Firstly, we have cross-sectional data and time series data. Cross-sectional data is collected at a particular time, while time series data show information collected over a period of time. The frequency table is used to show counted data. When we count something, we're counting the frequency with which it occurs. The data that's counted are called the scores, and the number of times each score occurs is called the frequency. Frequency table is also called a frequency distribution. So all of these terms are used when we're counting data. Frequency table, frequency distribution, scores and frequency. Finally, we have discrete data and continuous data. Both of these are numerical as opposed to categorical data, but discrete data can only have certain values, whereas continuous data can take any value within a certain range. If we're counting something, then we have discrete data, and if we're measuring something, we usually have continuous data. So we have 3 scenarios here, and for each of A, B and C, I'd like you to think about whether the data collected will be discrete or continuous, and time series or cross-sectional. So the first one is the heights of shoppers leaving a supermarket on a Saturday morning. Secondly, we have the number of items bought by shoppers at a supermarket on a Saturday morning. And finally, the number of shoppers at a supermarket on the 6 Saturday mornings before Christmas. So just pause the video and write down A, B, C, and for each one, discrete or continuous, and time series or cross-sectional. Sometimes for convenience, we group our data into intervals in order to make it easier to collect the data. So imagine we're back at that polling station again. We're going to collect the ages of voters. This time we're going to use a frequency table to collect the data. Our age intervals, we can group however we like, but I'm going to go 10 to 19, 20 to 29, etc. And it's usual to collect this sort of data using a tally system. So as the people arrive, we ask them their age. The first one is 43, then 41, and so on. As we reach the 5th score in a category, we cross the previous 4 to make a gate. And then the final column in a frequency table is called frequency, and it's where we convert the tallies into numerical frequencies. Now let's compare this method with the stem and leaf diagram that we constructed earlier. The advantages of the tally method are that it's much quicker to make a tally mark than to write down each of the individual numbers. And also, people might be more willing to give their age range rather than their actual age if we're collecting this sort of data. The problem with a grouped frequency table like this is that we've lost all of the original data. So this one person who's in the 10 to 19 range, we don't know their actual age. It could be anything between 10 and 19. But from the stem and leaf diagram, we do know that we have a 16-year-old. So when considering which method of data collection might be more appropriate, you need to consider the practical situation in which you're collecting the data and also what you're going to do with the data afterwards. Do you need to retain the individual scores, or can you work with grouped data?